Hello, hello, this is Mike. Welcome to Solutions video number 5. Looking forward to going through these new question sets with you. Let's get into things here and let's do it. So, for question 1. Question 1 has to do with fractions, decimals, and percentages. So let's talk about how to deal with these. When you actually have to deal with these and put them into your calculator, that's essentially what this question is about. Using your calculator and making sure that you can put these all into the same language. What do I mean by that? Well, a fraction, the number 1/2 is a fraction. In decimal form, that is 0.5, and in percentage, that is 50%. Those are all the same value. These are all the same. They're all in the same, or they're in different languages, but they say the same amount. So what do we need to do? Well, we need to convert these into the same language. Now, the language of calculators is decimals. Decimals, calculators love decimals here. They absolutely love them. That's what we're going to put these all in. So how did I get from 1/2 to 0.5? Well, this is in previous solutions videos. So let's just go through that. The first easiest piece is using my trusty calculator here to actually do the top number 1 divide the bottom number 2. 1 divided by 2 is 0.5. You'll see how that is the same there. So the top divide, I'll put it in this form, divide the bottom. Now, once you're in decimal form, then to go from here to here, you times by 100. So if I times this by 100, bango bango, 50, you'll see that this times 100 is this. Well, what does that mean if I want to go from percentage to decimal? Well, that means if I'm going this way, it's times, but if I'm going back up, so let me not put an arrow here. If I'm going just this way, it's times. If I'm going back up, it's divide. So if I take 50 and I divide by 100, I get 0.5. So I'm going to divide by 100 for the percentages. For the fractions, I'm going to take the top divided by the bottom. That'll get me the decimals. So what do I actually need to do here? In the question, well, I got 3/4 times 0.8 times 10%. Okay, well, which of those are in decimal? Well, this one's in decimal, so I don't have to worry about that. So 0.8, I'm going to switch markers here. 0.8 is already in decimal. So what's 3/4 in decimal? Well, I'm going to take the top and divide by the bottom. So if I do, we're going to clear that here. If I do 3 divided by 4, it gives me 0.75. So that is 0.75. And then 10%, well, what did I have to do? Well, I already said it over here. I have to divide by 100. So I'm taking just 10. I'm going to take 10. And I'm going to divide by 100. And that gets me 0.1. So 0.1 is 10%. So now I got 3 numbers that are all in decimal form. And how do I put that together? Well, I've been asked to multiply them here. So I'm going to take 0.75, my first number. I'm going to take my second number times 0.8 times my third number, 0.1. Bingo bango, 0.06. When I times all of those together, it equals 0.06. you can do this similarly, as I will show you when these turn into plus signs. You would just convert it all to decimal, and let's say we wanted to add all these together. So how would I do that? Well, 0.75 plus 0.8 plus 0.1 gets us a different number. So again, that other answer when those are multiplies is 0.06. If I'm going to add them all, I just do as simply 0.75 plus 0.8 plus 0.1. Bingo bango, 1.65 if these were all plus 1.65 would be the answer. So again, the key here is converting, right? Turn all of these into the language of decimals. I did that by taking the top dividing by the bottom, and I changed the percentage into the decimal by dividing by 100 here. So that should be fairly clear, fairly straightforward. It's a little bit challenging for sure, but let's move on to question 2. All right, question 2. Question 2, these are rate questions. So these are like a rate overall is like number of things per generally time. However, sometimes that can be like per other stuff. So a rate might be like dollars per hour. See how that's like a number of things, a number of dollars per time in this case, number of hours. However, maybe if it's not time, you can have dollars per project. Well, if I have 3 projects and I make this much money, then I can have this many dollars per project. You can see how that's not time, that's a different thing. I could also have like birds. I could be counting birds, and then I could have birds per minute. Right, that makes sense. How many birds did you see in a minute? And it would be like 6 birds per minute. But I could also have birds per square kilometer. What do I mean by that? Well, like birds over a space. So that's more, again, in this stuff, this area, this other thing. There's ways to measure, but these are all similarly rates. So rates have to do with a number of things per other stuff, which is generally time. Okay, so knowing all that, well, what are we actually dealing with here? So in this case, you take the top and you divide by the bottom. So division is going to be our friend here. Division is going to be our friend. So the importance is on division here, but let's go to the question. So the question, the first example is someone can fix 3 cars a day. What does that mean? Fix 3 cars per day. Try to get language where you're identifying that per, which means the line. It means that this is going to be divided by this. It means that 3 cars per day. Okay, so how many cars can he fix in a month? Well, I also ask what assumptions. So let's start with some assumptions. So what's an assumption? Assumption is like a best guess or something that we need to say is true in order to move forward. So an assumption here would be like number of days in a month. Number of days per month. If we're in February, that's going to be 28, sometimes 29, right? If we're in June, it's 30 days. If we're in August, it's 31. So the number of days can change. So which month are we in is an assumption. And then another assumption is that that rate is consistent. Like, I mean, it's not right to just believe that this guy can fix 3 cars a day no matter what. Like, what happens if a car is totaled? What happens if a car is like completely in shambles? Like, he's got to spend more time fixing it. This is like an average thing. It has to be an average thing, unless he just fixes tail lights or something, right? If he just does that one thing, then he can do 3 a day no matter what. So the rate is consistent. So if we have a consistent rate and the number of days per month, so let's actually do this math here. So we got 3 cars per day, and we're actually going to multiply by the number of days per month. So let's assume we're in February here. So we're going to assume February, which means that there's 28 days per month. See how this thing is happening where day and day are on the top and the bottom, which means we can cancel them, which means we're left with cars per month. It's almost like if you have a number up here, like an X up here and an X down here, you could cancel it. Same thing with units. So days and days cancel, and we're left with 3 times 28. Now I can just do some quick math here. Again, 3 times 28. 3 times 8 is 24. 3 times 2 is 6, plus 2 is 8. 84. So in total, we have 84 cars per month. So 84 cars per month would be the amount that we can get here. We had to assume some things. We had to assume, like, let's say February. Then we have 28 days per month, 3 cars per day, this many days per month. You multiply them through to get 84 cars per month. Rate questions are very similar to this. You're looking for this conversion. This conversion here is really the key. And the other key is me having markers that can work consistently. So let's go to the next question. In the next question, ooh, brand new fancy marker. So question 3 here. For question 3, we have a foot. So 1 foot equals how many centimeters? Well, this is where we actually need to go online, and we need to look, because the conversion is set. This rate is defined. Like, this is defined. You can't like guess this. This is like set. The 1 foot equals a certain number of centimeters. And so I'm actually just going to check my computer here, and I'm going to type in 1 foot in cm. So if I type in exactly this, right? 1 foot, the unit, in this unit, cm, it's going to spit out a number, and the number it spits out here is 30.48. So that is the number of centimeters in 1 foot. Given this, though, then we could do things like, well, what is 2 feet, right? 2 feet, that's the plural, would be double this, or 2 times this, which would be, again, 60.96. So that would be 2 feet. So you can see how you can scale this up, or you could also scale down. For example, what is 0.1 foot? Well, that's a stupid unit. No one would ever use that. But if you were given something like that, then you're not timesing by 2, you're actually dividing by 10. How did I do that so fast? Well, it's because a lot of the questions we've been practicing are saying that I just have to move the decimal point 1 in this, right? So If I'm moving the decimal point 1, I'm timesing or dividing by 10. And I know that I'm making it smaller, so I have to divide by 10. So what's dividing by 10? Well, it's moving the decimal point here once. So I'm going to have 3.048 centimeters. So 0.1 foot is 3.048 centimeters. These questions are going to get a lot more challenging, and there's going to be some fun and silly units going through here. So you always want to search on Google this number of feet, or in this case, it would be like this number of feet in this other unit, and that'll come up. But sometimes you're going to have to use some logic and convert that based on the number of feet or the number of centimeters, whatever it might be. So that is question 3. It's units, making sure that you're able to convert between all sorts of things so you don't get stuck. Okay, so let's get over to question 4 here. So moving on to question 4. Question 4 is a rate question. So what do I mean by rate? Well, a rate is, let's say in this case, just like question 2, we're going to have dollars, sometimes per hour. That's a rate. This is like a wage you might be getting paid. Sometimes if you're getting paid by the year, then that might be a salary. So we're looking at rates, we're looking at money here. So what does that mean? Well, a rate is an amount divided by a time. And so all of these questions are going to be kind of connected to this. So how do I also reorganize this? Well, if I have an amount in this case of money, and I need to calculate that amount, I'm going to move this time up, so I'm actually going to have the rate times the time. So the rate times the time here equals the amount. Now using this frame, this is what I want to make sure that we're clear on for in this particular example of a question. So we've got different ways to write this same equation here. And we need to figure out which ones that we need for any given amount of information. So let's say I was given in the question example $1,000. And what else was I given? Well, I was given 40 hours. 40 hours per week in this case. So that's like a time. 40 hours is a time, $1,000 as an amount. So if I have 1,000 and then I'm going to divide by time, I'm going to get the rate. So we're using this version of the equation here, not this one, but that might be useful elsewhere. So I'm actually going to have the amount, 1,000, divide by 40, and that's going to be the rate that I would have to make, or the salary. So if I pull out my trusty calculator here, and I plug in 1,000, 1,000, divide by 40, I'm going to get 25. So 1,000 divided by 40 is 25. So what does that 25 mean? Well, that's $25 per hour is what I would need to get paid, or the rate. There's lots of different versions of this question. Let's say I gave you a pay rate of $25 per hour. Let's plug it in here. And then I said you work for 1,000 hours. If you work for 1,000 hours at $25 an hour, you're going to make $25,000 because I did this times this to be the amount. So you can see here that depending on how I do these questions, the rate equals the amount over the time is an important way, an important equation here. Let's move on to question 5. Okay, so we've got question 5. Question 5 is all about circles. what's going on with circles? Well, let's say this was a perfect circle. Really hard to draw a perfect circle. And let's say that I've got this amount here. Well, that, like, from the midpoint, right in the center of the circle, to the edge is going to be the same value. So imagine that's the same as that, which is the same as that. All of these lines are the same length if it's right in the middle. That's how a circle is like defined. So this is called the radius. The radius is like from the middle to the outside. Then a diameter is all the way through, diameter, all the way through a circle. So if you draw a line from one side straight through the middle to the other, that's a diameter. You can get some other complex stuff in circles, but these are the two most important pieces. So let's call the radius R. Let's call the diameter D. Now, there's going to be two kinds of questions that I'm going to give you. One is the circumference. So circumference. So the circumference here is equal to 2 pi r or d pi. What do I mean by that? Well, I mean d times pi, or I mean 2 pi r, or 2 times r, this half amount. But see how d is actually just the same as 2r? Like 2 of these r's is just d here, the diameter. So these are actually saying the same thing. But what the heck is this pi? What is pi here? You might have heard of this letter pi. It's a strange letter that actually comes from measuring the length of all the way around of half a circle. So this would be pi. Do you have to know that in detail? No. But it kind of comes down to this definition of the circumference is connected to pi. Just know also that pi is the same thing as 3.14159. I'm also going to accept 3.14 for pi. It's just literally a number, 3.14. So pi is the same thing on your calculator as 3.14. You can just plug in that in this. So let's do an example here. This is kind of the theory with pi, with radius, with diameter. Circumference, we're also going to do area, but let's do that in a moment. So questions are going to be like, if I've got a circle and I've got a radius of 3, let's say centimeters. Well, if I've got a radius of 3 centimeters, imagine this is a perfect circle, then the circumference, which I'm just going to say is is equal to d pi. Okay, what do I mean? Well, I mean that the diameter here is, if this is 3, then this is going to be 6. So going all the way across is going to be 6. So the circumference equals 6 pi, which equals 6 times 3.14. So I pull out my trusty calculator here, and I do 6 times 3.14 equals 18.84 centimeters, because it's the same. That is the circumference. Now, what if I wanted to do area? Well, area is equal to pi r squared. R squared. So it's r, don't forget, squared. Squared is not times 2. Squared is times by itself. So in this case, what would this circle be with an r of 3? So we'd have the area of pi 3 squared. We'd have pi times 9. And let's get an actual number here. So again, I'm going to bust out my calculator. And I'm going to say 9 times 3.14. Bingo, 28.26. So I've got r squared times pi, 3.14. Again, pi is 3.14. And that is question 5. Okay, so let's move over to question 6 here. Let's go to question 6. Question 6 are the standard fraction questions. So what do I mean by standard fraction questions? Well, I mean that we're going to have, let's say, 1/3 plus 1/7. We're going to have 1/3 minus 1/7. We're going to have 1/3 times 1/7 and 1/3 divide 1/7. This is reviewed longer in other videos. It should be assumed content knowledge at this point, but I'm going to give a quick refresher here. So what do? Well, you need to put, for addition and subtraction, both in a thing called a common denominator. Common denominator, meaning the bottoms need to be the same. So I'm going to have to multiply that by 7. How do I know? Well, it's because there's 7 over here. I'm going to multiply this by 3 because this is a 3 over here. But whatever I do down below, I got to do up top. So I'm going to multiply that by 3, and I'm going to multiply that by 7. So what did I do? I took this number on the opposite fraction and multiplied the bottom and top by that number. So I got 7 times 1 is 7. 7 times 3 is 21. Plus 3 times 1 is 3. 3 times 7 is 21. Oh my God, those numbers are the same on the bottom. That's exactly how we planned it. Now you just add the tops. The bottom stays the same. Stays the same. And then on the top, it's 10. 7 plus 3 is 10. Subtraction, same deal. We're going to do this, multiply by 7 top and bottom, multiply by 3, because we can't do it any other way. So we're going to get 721 minus 3 over 21. What does that get us? 7 minus 3 is 4. Bottom, I know you know this. Bottom stays the same. 21, 21, and 21. Bottoms stay the same when they are the same. Addition and subtraction of fractions is the hardest. You have to convert it. How did I get 21? Well, 3 times 7, so these two bottom numbers combined. Then how did I get the top number? It's the opposite fraction bottom number. So in this case, it's 7. In this case, it's 3. Cool. Multiplication, ultra easy. Multiplication is super easy because you multiply the tops and the bottoms. You get 1 times 1 is 1. 3 times 7 is 21. Boom, done. Wasn't that so much easier than all this garbage up here? But sometimes you got to do it, so we totally understand. Division. Division is like a secret multiplication question. What do I mean? Well, this is the same as writing the first number, the first fraction, times flipping this, 7 over 1. What? That doesn't make any sense. Division is just multiplication flipped. As weird as that sounds, 1/3 divide 1/7 is the same thing as 1/3 times this flipped 7 over 1. Now we just do the tops. 7, 1 times 7 is 7. 3 times 1 is 3. Bingo bango, you got yourself all the fraction questions as a reminder. Cool, let's go into question 7. Question 7. Scientific notation. This is a bit of a new thing, but essentially here's what it means. If I give you a really ugly long number, 38600000000, and what the heck, let's throw in some more zeros there, 000. So I got 3, 6, 9, 10, 11 zeros, and those are just commas there to show. This number How would I read that number first of all? Well, this is like 1,000. Would be a million. So that's 1,000. That's a million. This is a billion. This is a trillion. This is 38 trillion. That's how we would like think about that. But is that what this is about? No. So just a nice thing to be able to identify. This number, 38.6 trillion is how I would say this, can be written simpler. And how might that be? Well, turns out I can just times a small number, let's say 3.86, times 10 to the however many zeros there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 zeros plus however many more decimal points I had to move. So I moved 1 and 2. So 10 to the 13, 3.86 times 10 to the 13 is this number. If you doubt me, do it on your calculator. But this is a faster way here to write massive numbers. Now I'm going to ask you to go from this form into the full form. I'm also going to ask you to go from this long number into, this is called scientific notation. Scientific notation. We use it for large numbers. So how did I do that again? I took the first digits. I did like a ones digit on the very first one, and then I did a point. 86. Then times 10 to the, how did I get this number? It's always times 10 to the. How did I get this number? I counted the number of zeros and then added the number of decimal places here. So that was 11 plus 2 decimal places. Gets us up to 13. Let's just look at another possible question here, just so you can see this right beside. If I've got, let's actually do a simpler one. Let's say 380,000. So I've got a number that I can write in scientific notation. And how am I going to do that? I'm going to write 3.8. Because this is 3 and 8 are the first same numbers. Then how many zeros? Well, I got times 10 to the 1, 2, 3, 4. Plus one of these is 5. If you doubt me again, do that on your calculator. 3.8 times 10 to the 5 is going to be 380,000 there. That is scientific notation. It also helps us get a sense of these like exponents, what to do there. So let's move on. Going to question 8. Question 8. Question 8. Powers, right? 2 squared is 4. But that's not because it's 2 times 2 here. Because 3 squared is 9. It's not 6. 3 squared is not 6. It's not 6. 4 squared is not 8. It's 16. What? It means 4 times 4. It means this thing times itself this many times. We're also going to have situations where maybe you do 4 cubed. What does that mean? Well, that means 4 times 4 times 4. That's going to get 64. So 4 cubed is 64. 4 squared is 16. Notice that this 64 is just 4 times 16 there. Again, reminders, this should be fairly consistent, but what are we going to get? We're going to get a bunch of different kinds of questions here. So we're going to start with questions that are like 10 squared minus 9 squared plus 8 squared minus 7 squared. Well, how do I do this? Because these are chunked, there's a chunk here, 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 and here. I just solve each one of them. 10 squared, I can do it on my calculator, but I can also do it in my head as 100. 100 minus 81, 9 squared, plus 8 squared is 64, minus 7 squared is 49. So 100 minus 81, again, could do this on my calculator, but I'm just going to do it in my head. I got 19 plus 64. 19 plus 64 is 74, 83. 83 minus 49, well, that's going to be 34. So 34 plus 49 is 83. We got a final answer here of 10 squared minus 9 squared plus 8 squared minus 7 squared is 34. That's one example of questions that you're going to get. And as we get into a little bit more complicated, we're going to see some power rules come up. So we're going to see like 2 squared, squared again. Well, what does that mean? Well, I could do 4 squared. That would be equivalent. But I could also do a power rule here, which would be you multiply those together to get 2 to the 4. So similarly, that same power rule would be like 3 squared to the 3rd. I'm going to get 3 to the 6th because I multiply those together. That's one kind of rule that you might see in these questions. And another rule that you might see is that if I have 3, let's say, squared plus 3 squared times 3 squared, well, then I'm just going to add those two fractions. So here I multiplied it, right? I got 2 times 3 is 6. But here, that's like writing out 3 times 3 times 3 times 3. Well, that is just 3 to the 4th. So I multiplied 2 times 2 to get 4. Let's give another example. Let's do 2 to the 6th, that's terrible, 6, times 2 to the 10. Well, rather than writing that out that many times, I'm just going to add those two numbers, and I'm going to say 2 to the 16 there. 2 to the 16 would be 2 to the 6th times 2 to the 10th, 2 to the 16th, because you add those together. Those are all the examples that we're going to kind of weave within these power rule questions. Again, hope you're able to integrate those into the other basic algebra. We'll get a little bit more complicated. Some of these should be a little challenging, but we want to understand powers and the power rules a little bit more. Let's move on to question 9. Question 9. This is algebra. Algebra is essentially getting the x's on one side, get x there, and then get numbers there. What do I mean? Let's give an example. 2x minus 5 equals x plus 2. I want to get all the x's onto this side, which means I need to subtract an x here. If this is pushing your boundaries already, if you're like, why are you subtracting an x? We need to talk. Please do ask me. You need to do a lot of practice here to catch up on basic algebra. I'm going to take x, subtract x, and because I subtract an x on this side, I have to subtract an x here. 2x, take away an x, just gives me 1x, or just x. Minus 5 equals, well, those canceled, and I'm left with plus 2. Why did those cancel? X, take away something, take away itself is nothing left there. So I got 0 x's plus 2. Then I have to add 5 to both sides. Add 5 here to get rid of that 5x, or that 5. So I'm left with the x because I didn't touch it. 2 plus 5 is 7. See how the whole way I got all the x's on this side. And then the whole way, I also moved all the numbers onto this side. So I got x equals 7. Let's do things that are a little bit more complicated here. Let's turn up the heat. Let's say I got 2x plus 1 over 3. And then I have equals, let's say 2x minus 10. This is probably going to get me a wild number. So let's just assume that the number is going to be really weird. Let's go for it. Actually, I'm going to change that to 4. No, I'm not. I'm going to change that to a 6. Let's see how that goes. Okay, here we go. So how the heck do I do this? Well, you got to think about operations. You got to think about moving the x's to this side, moving numbers to this side. But I can't touch this until I break it apart. And how do I do that? Well, I'm going to times each side by 3. If I times each side by 3, so that's not 3x, that's 3 times. Then I'm going to cancel this bottom, and I'm going to have 2x plus 1. But I did a times 3 to this whole side. I got to do a times 3 to this side, which means 3 times 6x minus 10. You might also notice that this is now the distributive property. What do I mean? I got to times this, times that, times that. Well, I got 3 times 6x is 18x. 3 times minus 10 is minus 30. So I got 2x plus 1 equals this stuff. Well, now this looks a lot like that other problem. I just had to get rid of these first complicated bits. So I got 2x plus 1 equals 18x minus 30. I want to move all the x's over to this side, so I'm going to subtract 18x. That's going to get me minus 18x. So I'm going to have minus 16x on this side. But I'm also, in this same step, going to subtract 1 to move it to the other side. And if I subtract 1 from this side, that's going to cancel that. But I'll have to subtract 1 from this side. So I'm going to have minus 30 minus 1, which is minus 31. What the heck do I do now? Well, let's go over here, and I have to divide both sides by negative 16. I'm going to undo this negative 16x. That's going to leave me with x equals negative 31 over negative 16. As weird as that sounds, I was really close to guessing. I was so close. I was so close to this being 32 over 16 and then x equals 2 that I couldn't quite intuit it. But I was close, so give me props on that. In this case, again, each step is here. This is like the hardest kind of algebra that we're going to tackle together. If you can do a question like this, you are rocking it. If you're struggling, there's lots of Khan Academy videos and other things to help understand. This is the language of math. This is like as high level as it gets this year. But let's make sure you get fluent in that. So we'll leave it at that. Again, please ask me if you need any support, and let's go over to question 10. Question 10, graphing. Graphing is a good time. We're going to graph stuff. How do we graph? Well, first things first, we write out what we're graphing. Next step, we're going to t-chart it with x and y. And the final step is we're going to plot those points. Those are the 3 steps. First step, write it out. Second step, we're going to plug in negative 2, negative 1, 0, 1, and 2. I need negative numbers here, and I need 5 of them because we're moving into the world of quadratics. So what do I mean? I mean that we're going to get a shape that is unlike anything we've dealt with so far. We have dabbled in it. So you might be a little bit familiar, but we're moving on to the 10-question quiz with this. So what do? Well, I take x, and let's start with 0, just because I appreciate that. If I plug in 0 to x squared, 0 squared is 0, which means that is y. Notice how when 0 goes in here, 0 times 0 is 0, y equals 0, y equals 0, written here. Cool. Next step, let's do 1, because I think that's also easier to just get us warmed up. 1 times 1 is 1. Y equals, this number equals 1 squared, 1. 2 squared is 2 times 2, which is 4. Notice how this starts to change. This looks a little bit different. right? It's not increasing at the same rates, it's increasing at a different rate. Well, let's now try the more challenging one, the negatives. Negative 1 squared. Don't forget, a negative times a negative is a positive. So we've actually got positive 1 here. 1 times 1 is 1. Negative 1 times negative 1 is positive 1. Just like this would be positive. Then negative 2 times negative 2, that's going to be positive 4. Well, okay, how do I graph these? Well, let's say the 0, 0 is right there. That should be common knowledge with our graphing so far. 1 and 1 is 1 step over, 1 step here. 2 and 4 is 2 steps over and 4 steps up. Then what about 1 step this way, negative 1, plus 1 is here. And then 2 steps over and 4 steps up is here. Notice how these are symmetrical. They look identical, and if I connect the dots, it's a big U. This is called a quadratic. Super important to know this. This is like grade 10 math in a nutshell here. It's important that we know how to graph these, that we know how to mess around with these a little bit. Let's try a different one. I'm going to try a quite complicated one. We're not going to get there quite yet, but let's see what we can do. If you are asked to graph, let's say, y equals 2x squared minus, let's say, 3x plus 5. Actually, I'm going to say that plus 1. All right, we got that. Now, we got a t-chart. You could try to do that in your head if you want. You could try to work on it yourself and pause the video. But the first way we start, negative 2, negative 1, 0, positive 1, positive 2. Alrighty, so let's actually get into how to do this question. It's the same as the other one. We're going to find for every value of x, there's a corresponding value of y. We're going to do that by plugging in these values to here. Then the value that all this math spits out is going to equal y. See, like y equals all this stuff. So we just solve this stuff and then we get y. Y is equal to that. Let's actually start with 0. So let me write this out once, just so you can see what I'm doing. So I'm going to drop the, well, actually, let's do the y equals. So y equals 2 times 0 squared. See how this is 2x squared? Well, I'm plugging in 0 first. We're going to start here on 0. Then I've got minus 3 times 0. Then I've got plus 1. See how I plugged in x, which is in this first case, we're just trying to solve this one number. I'm going to plug in 0 for x there and x there, so that's what we did here. Then 0 squared is 0, and 0 times 2 is 0. So I got 0 minus 3 times 0. Well, you can do that on your calculator or in your head, but that's 0. Plus 1. 0 minus 0 plus 1 is just 1. See how I solved all that stuff? Now I got y equals 1, so 1 is the answer for the corresponding 0. But I still have to do this one, this one, this one, and this one to show me the rest of the graph when we actually put it all together. So let me do a quick erase here. Let me show the other example in here, and then I'll just do some quick math. So we got x equals 1. If I put 1 in here, and I put 1 in here, so I'm going to do 0, 1 first, because I don't want to deal with that negative yet. I'll deal with that next. So 1 squared. 1 squared is 1. 1 times 2 is 2. Then minus 3 times 1, which is 3, plus 1. I got 2 minus 3 plus 1. 2 minus 3 is minus 1. Then plus 1 is 0. Y equals 0. See how there's no like pattern? You can't predict this. I couldn't have looked at this and been like, yeah, when x equals 1, y equals 0. Maybe if you're so familiar with these kinds of things, you could, but really not. That's not possible. So let's do some shorthand then, and I'm just going to erase this, and I'm going to kind of power through. So if I plug in 2 to here, I'm going to get 2 squared is 4, times 2 is 8. 4 times 2 is 8, minus 3 times 2. Well, 3 times 2 is 6, plus 1. 8 minus 6 is 2, plus 1 is 3. So I got 3 right there. You might, from this, be able to figure out a pattern. I'd be impressed if you could predict these two numbers right now, but let's actually see what this looks like. So, negative. I'm going to plug in a negative number here. Negative 1 squared. What's negative 1? It's positive 1. Negative 1 squared is going to be positive 1, and positive 1 times 2 is 2. Then 2 minus 3 times minus 1, well, that actually gives me a positive. Minus 3 times minus 1 is positive 3. 3 times 1 is 3, minus times a minus is a positive. Then plus 1 doesn't change. I got 2 plus 3 is 5, plus 1 is 6. I got an answer of 6 here. Couldn't have predicted that using these, unless you know where the vertex is. That's a whole other story. Let's talk about that in a minute. Okay, so we got minus 2 now. Minus 2 squared is positive 4, times 2 is 8. So I'm plugging that into there. Minus 2 squared is 4, then 4 times 2 is 8. Minus 3 times negative 2, negative 3 times negative 2 is positive 6. So that actually turns into a positive. And then plus 1, 8 plus 6, 14, plus 1, 15. I got 15 there. So clearly something wild and weird has happened in here. A couple things. Now I'm actually going to graph this thing. So let's make sure that we get really accurate with these points. So again, this is the x, this is the y. The first number here in the ordered pair is 0. I go 0 in the x, it's right in the middle. Then 1 in the y is 1 up. So that's a point right there on this graph. 1 over in the x and 0 in the y. That would be right here. So that's 1 over in the x and 0 in the y. 2 over in the x and 3 up would be about here. Then negative 1 over and 6 up is going to be somewhere like here. And then negative 2 over and 15 up is going to be like way up here. So what do I see? Well, I clearly see something that's going down here. It's coming in here. And it starts to curve pretty quick there. So I'm actually going to guess it drops right below, just before that, and already is coming up like that. How did I articulate that exactly? Well, you could find these numbers. That's a bit more complex than we're going to do in the 10 questions. We might try to do that as bonus questions here. But could you sort out exactly where that is? Yes. You just have to solve for more numbers in here. You'd have to solve for like 0.5, see what came back, and then get some clarity in there. But this is, again, in general, the shape, it's a little bit more narrow because of that 2. So the 2 made it a bit more steep. And then this plus 1 gave it that value right there on the y. So again, this is graphing quadratics. This is the most important piece. Actually being able to draw them is very important as well. I hope that explanation works and should be enough to get you through the 10 questions. Thank you very much. Thumbs up, and yeah, enjoy quadratics.